Uh, Today we are going to discuss about relational algebra. Yesterday we have seen by using the command line SQL command line we have written PLSQL programs, and by using Notepad we are able to write the PLSQL program, and by using IDE, that is SQL Developer IDE, so that also we have used. So in this way we can execute our PLSQL programs or SQL queries. So in today's session, we are going to discuss about relational algebra. See, relational algebra is a procedural query language, which takes a relation as input and generates relation as a output. Here, relation means what? Table. It takes a table as input and it gives the output as table. So, relational algebra is a language for expressing relational database queries. So, this is also one language for expressing relational database queries. Actually, before SQL, we have used only the relational algebra and relational characters to perform the operations. That means if you are writing SQL queries inside what language is working, relational algebra language is working. It uses operators to perform queries, as an operator can be either unary or binary. So we have two types of relational algebras here. Two types of operators in relational algebra, two types of operations we can perform. First one is basic or fundamental operators. So we can use two types of operators here, basic or fundamental operators. Next to additional or derived operators. Okay, here the relational algebra operations works on one or more relationals to define another relation without changing the original relation. Okay, the relational algebra operations are performed recursively on the relation. We can perform recursively on the relation, means table on the, we can perform operations, relation algebra operations recursively on our tables. Okay, so see here, basic or fundamental operations what we can perform is the selection operation by using sigma, projection operation, symbol is what? Pi symbol, union symbol, difference, minus symbol, Cartesian product, that is cross product. Already we explained about this in unions, right? Union, intersect, we have done SQL queries for that. So same thing here also we will apply by using algebra. Okay, so not like our SQL queries. Okay, and Cartesian product means multiplication. So next rename, we represent with a row symbol, row. And coming to additional or derived operations, we have natural joins, division and assignments. So joins means we have natural join, left join, right join, outer join, full outer join or outer join, we can say it. Okay, a natural join we can represent with this symbol. Full join means left join means, see, this is the symbol, and right join means this is the symbol. Okay, full join means it having both symbols here. Okay, next set in intersection, this is the intersection symbol. So next division, next assignment. So these are all the operators for algebra. See, here select, project and rename are unary operators. What are the unary operators here? Select, project and rename means sigma, pi and row symbols are unary operators because they are operate on one relation, only on one relation, means we can perform operation on one table. Okay, by using one table we are going to select a project or rename it. Okay, next union, difference, Cartesian product or binary operators. So what are the binary operators? Union, difference and the Cartesian products or the binary operators because they operate on two relations. So if you have two tables, then only we can perform union, different, Cartesian product operators we can use there. Okay, remember that symbols we are going to perform operations. See here. First one is what? Select operator. First one, select operator. Select operator symbol is what? Sigma. See, select operator is a unary operator. It is a unary operator in relational algebra to perform the select operation, selection operation. This selection operation not like our S. If you use select, whole row will be displaying here. That is select. We will see the syntax. Okay. Next, it selects tuples. Here, select operator means what? It selects tuples. Tuples means what? Rows. What are the tuples? Tuples means rows that satisfies the given condition. That satisfies the given condition or prediction. Predicate means here what? Condition from the table. We are going to we are going to retrieve the rows condition. Okay, that's about our selection operation. So how we can denote it? By using sigma symbol. Okay, next, what is the notation? See, sigma p means predicate means what? We are going to write the condition. Then r means relation. Sigma means selection, then condition, then this is the relation. Relation means table. Or how we can represent this one? See, this is the syntax for select, to perform select operation in relational algebra. This is sigma. This is the first relation. You can see where we can start, from where we can start the execution, right? We can consider from right to left, right to left. In this way we can move from this to this. Means first we need to write the table name we are going to write here. Next, condition, that is from select is the symbol here. So now here p is what? So p is used as a proportional logic formula which may use logical condition. So instead of p here, what we can write here? Condition means what type of conditions we can write? And operator we can use, and or not. Logical operators we can use, and the relational operators like equal to, not equal to, less than, greater than, or less than or equal to, or greater than or equal to, we can use. Okay, we can use here. Okay, see here, where class of a SQL command corresponds to the relation select sigma. Okay, see our SQL query like this: select star from relation means table name, where condition C. So this is what we are writing in SQL. If it is in relational algebra means the syntax will be like this. See, for example, here we have an example: select tuples from student table whose age is greater than 17. How you can write? How to write in SQL? Select tuples from student age is greater than 17. Select id comma name from table name emp where age is greater than 70. Okay, in this way we are writing in SQL. Okay, now how to write by using relational algebra? So this is the query here. This is the query. This is the query. See here we have a table, student table. Student properties are student roll number, name, then age, then address, right? See here, first select tuples from student table whose age is greater than 17. Select tuples from which table? Table name is what here? Student. Then write student within the bracket. We are able to write student. So that is table name. Okay. Table whose age is greater than. Select the tuples. Means select the rows. I want to select the rows. Select the rows means what is the condition? What is the symbol? Sigma. Here condition is what? Age is greater than 17. Here column name is what? Age. So age is greater than 17. So in this way we need to write the query. That means what is the output here? If you write this query, what is the output? It is going to select where age is 17. So this is the output. How can I perform this? Okay, you already know in SQL. So what are the ages below 17? So those data we can select here. 17, above 17, right? Age is above 17. Above 17 means 19, 18, 20. These rows, all the rows we can print here. Okay. Next query, see the next example. Select student whose roll number is 2. Select the student whose roll number is 2. Okay. Select the student. So we selected the student. So this is the student table. From student table, which row you want to select? Roll number, where roll number is 2. So sigma roll number is 2. You need to write like this. Then what is the output? So this will be the output from this table. Okay. Are you understanding? All of you. Next, you understand select operation, right? So in this way we have some example, we need to solve it. So here another condition. So select students whose age is greater than 17. Whose age is greater than 17. Here the table name is student. We are representing here. And the condition is what? Whose age is greater than 17. Here we are writing the condition. So here what I should do, display all the rows. All the rows means I used a symbol like this. Okay. We are selecting rows. Which rows? Where age is greater than 17, above 17. We are going to display the data, all the rows. Means this symbol means all the rows we are going to display. Sigma symbol means all the rows we are going to display from the table. So this is the query. So in this way they will ask the questions. Okay, by using relational algebra. So write query for this. So select student whose age is greater than 17. Then you should not write query like select name ID from student where age is greater than 17. That is SQL query. But what here they asked means, here they ask the algebra, relational algebra query. We need to write relational algebra query. In this way you can write it. So in this way you need to write. This is the question, you need to write answer like this. Okay. Next, see the next query. See here, select students means student table whose age is greater than 17. Here we have the condition, and who lives in Delhi. Okay. See here we find the table name and the column name is A's and lives in Delhi. Delhi means what? Address, right? So column is address. We have columns A's and Delhi. Okay. Here A's is greater than 70, first condition, and the second condition is what? Address equal to Delhi. Address equal to Delhi. You need to understand like that, and then you need to write the query. Okay, want to display all the rows whose age is greater than 17 and who lives in Delhi. See, our table name is student. I have write to the student. Then address is what? So address who lives in Delhi means address equal to Delhi, and age is greater than 17. Age is greater than 17. Age is greater than 17. So in between what condition I need to write? And condition, and I have written. So I want to select all the rows. So I used sigma symbol. Okay. In this way we need to write the relation algebra query. Okay. Next. So then what is the output for that? See, this is the output from student table. So age must be greater than 17, that means 20, 19, 18, and the next condition is what? Address equal to Delhi. So here address is Delhi and address equal to Delhi. Next to 20, it is not satisfying the condition, so we are going to display only these two rows. So this is the output. Next, see next. So in exams they will ask like this: select tuples from relation books. Here relation means table. Table name is what? Books. Where subject is database. Where subject is database. Where condition I need to select the tuples. Select the tuples means select the rows from books table where subject equal to database. How can I write the query? So books is a table. Okay, table name. Then I need to select the subject where subject name is database. So subject is a column name, the value is database. Select all the tuples, right? So I used sigma symbol. Then this is the query to select rows from the books table where subject equal to database. Okay. Next, see the next query. Select tuples means I need to use sigma symbol from relation books. Relation here table name is what? Books. So you need to use sigma symbol. So where subject, here where condition, where subject equal to database. This is what? Column name. This is the value. Here another condition, and price is 450 means price equal to 450. We have under condition. So where condition? See how can I write the query? See your table name is books and the price is what? 450 and the subject is database. Select all the rows from this books table. Okay, in this way I need to write the query. This is the answer for that question. Okay, in exams also they will ask like this: select tuples from relation books where subject is database and price is 450. Write algebra query, not SQL query. So then you need to write query like this. Okay, are you understanding this? All of you see my next query. Here see, select tuples means select all the rows from relation books. Here table name books where condition subject is database, where subject equal to database. Here and condition Next price is 450. Price equal to 450. Next R condition. See R condition. Have publication year after 210. After 210 means above 2010. Above 2010. Where year greater than 2010. Where year greater than 2010. You want to display all the rows. So you write the query for algebra query here. So books is the table name. Next, see the condition. See the condition. Subject is database. Subject is a column name, value. In between, you need to use and condition. Okay. Next, price. Price equal to 450. Next, R condition. R condition. This is R condition. R. Then year publication year after 2010. 2010. After means above 2010. So year must be above 2010. So in this way I can write the query. Okay. Now this is the question. You need to write the answer like this. Are you understanding?
Yes, sir.
Next, that is about select operator. Next we will see the projection operator. Projection operator. This is the symbol projection, pi symbol. So projection also unary operator. I said what are the operators we have? Select completer, right? Select completer. Next projection, that is also unary operator. That is unary operator. Okay. In relational algebra, that performs a projection operation. Projection operation we can perform. Project means displays a particular columns. If you are using select operator, what we are going to perform? Select tuples, select rows. You are selecting the rows. Coming to projection, what you are selecting? Particular columns. We are displaying particular columns or attributes. Columns are attributes from relation. Relation means table, and it deletes columns that are not in the projection list. So if that list is not available in the projection, so it delete that columns. Okay. So how we can denote the projection operator? By using pi symbol. Okay. Next notation, how can I write it? This is pi symbol. A1, A2, A3, A4, A4 and so on. AM. These are all what? Columns are attributes, or how can I say, pi attribute list and relation name or table name. We need to write like this. This is the syntax. Okay. Here A1, A2, AN are attribute names of relation R, attributes names of table. Okay. Here duplicate rows are automatically eliminated from the result. Here we are not allowing duplicate values because we are using projection operator. Okay. Next, see this is SQL query. SQL select command corresponds to the relation projection. We use select query right there, so that corresponds to relation projection. Projection means display the columns, name, roll number, age, address. The data we can display only single column. It is regarding to columns. Select regarding to the rows and projection regarding to the columns. Operations we can perform here. So select A1, A2 and so on, AN from R relation. Here R means relation. Relation means table. Okay. What is the example? See the example. If I want to display the columns, roll number and name, roll number and name from relation student. We have a student table. I want to display roll number and name. How can I display? Select roll number comma name from student you are writing in SQL query. But here, how you can write? In relational algebra, how you can write? So find the table name. What is the table name here? Student is the table name. What I need to display? Which columns I need to display? Column roll number and name. So use pi symbol, roll number comma. Use comma separator for each attribute. Roll number comma name. See pi symbol. That means select roll number, select the columns from student table. It is going to display the table with roll number and name columns. Okay, that's what projection. See the example, we have example here. See, we have example. Have a student table, roll number, name and age. Query: display or project the names of the students in the student table. Only project name. Project the name. Here projection symbol this one, and the table name is what? Student. Student pi symbol and name. We are selecting name from student table. What is the output? This is the output. We are selecting only the name. That means this whole column we can display. Whole column data we can display. Okay, understand, right? Projection represents columns. Selection represents tuples, means rows. Okay. Next query. Sima here you need to understand. Then only you can write these algebra queries in exams. These are not important for interview, but in your exam they will ask. So that's why you need to learn it. Query: display the roll number and name of the student in the student table. So what is the table name here? Student is the table name, and what are the columns we are going to display? Roll number and name. Then tell me, how can you write the query? Student is a table, and what I need to display the columns? So roll number and name. Roll number and name I'm going to display. So use pi symbol. Okay. So what is the output? We are displaying both roll number and name. Are you understanding? If I give query, you need to write the algebra query, relational algebra query. In that way you need to prepare. Okay. See, we have completed select operator and projection operator. Now see the set operators. Set operators. We have union, set intersection, and set difference. Okay. Union. We already used these symbols. Used this query in SQL. Same logic, but we need to write the query first. Okay. See. So union is fundamental operator, and the intersection is derived operator, and difference is fundamental operator. Okay. See, suppose we have R and S are two relations. R and S are the two relations. The union operation selects all the tuples. The union operation select all the tuples that are either in R or S, or in both the relations, So it eliminates the duplicate tuples. So duplicate rows going to eliminate. Okay, it doesn't allow duplicate tuples. See, for union operation to be valid, following conditions must be hold. So if you are performing union operation, what is the rules we need to follow? So what is the rules we need to follow if it is union operation? If you perform union operation, the two relations R and S both have same number of attributes, same number of attributes, same number of attributes. Number of attributes must be same. In this table, number of attributes ID and name. Here also SID and SName. Number of attributes must be same from two tables. Okay, next, the corresponding attributes means that columns have same domain type. Domain type means here data type marked. Here id data type is what? Integer. Here sid data type is what? Integer. Must be same. Okay, otherwise we cannot perform union operation. See, two conditions. So both the tables having same number of attributes. Okay, and the domains means the data types must be same. The attributes Rn must be occur in the same order. So order also same. Duplicate tuples should be automatically removed. Duplicate tuples we can remove here by using union operator. See the diagram here. This is R relation. This is S relation. Means R table, S table. We having the data 1, 2, 3 in S 2, 3, 4. If you perform R union S, R union S, R union S. So in this way you can get it. This is the output. Okay. Common columns 2, 3. 2, 3, 2, 3. Okay, we are avoiding duplicate values and that must be having same. So that is the output here. Next, what is relational algebra? Relational algebra we can perform R union S, and this is the notation. What is the symbol for union operation? This is the symbol. And how can you write query, SQL query for this? Select star from table name union, select star from table name. Okay, in this way we are performing SQL. But in relational algebra, what is the query? In relational algebra, what is the query? How can I perform? Okay, see, we have two tables, student table and employee table. We have two tables, student table and employee table. Okay, student having roll number and employee having employee number. See, here condition we are satisfying or not while creating tables. So here attributes, this attributes, total number of attributes must be same and the domain must be same. Here roll number integer, here roll number also integer. Here we have total two attributes. We have here also two attributes. Condition satisfied. Next to domain. Here int or number. So here also must be int or number. Okay. So domain means data type. So must be same. Okay, satisfying. We have order also same. See here, how can I perform union operation with the relational algebra? Two tables, student have student roll number, student name, employee have employee number and employee name. See the so what is the table name? Student one table, employee one table. What we are going to display? The columns called name. We are going to display the name from two tables. So union of student to employee. You are performing union operation between student table and employee table. Which column you are going to display? We are going to project. Column name is name. Only we are projecting name column. So do union of student to employee. Next, then what is the output? This is the output. How it is the output. How? See here, names. See the names. We should not display duplicate operation. First compare A, B is duplicate, so we should display only one time A, then B, then C, next to D, next to G, next H. This is the output for name column. So we are performing union operation with the column name. Okay, this is the query you need to write for while you are performing union operation. Okay, you are projecting names of student and employee by using union operator. So now this is the output. Okay, remember this query. Okay, yes, all of you, are you understanding? CR, are you there?
Yes, sir.
Okay. See, next intersection operation and difference operation. Difference means minus. Minus means what? Only one table data we are going to display, that is not in the second table. That is not in the second table. What is the output? If you are use difference, display only first table data which is not present in the second table. That is difference, right? Tell me, what is the output here?
One.
One only the output. So how I can write relational algebra for this? Use set difference. Symbol is what? Minus, right? We can use minus symbol. If it is intersect symbol is what? This one, right?
The common elements of both instance.
Yes. So in that way we can perform operations. So in the next session we will see intersection, difference and all. Okay, if you learn this, okay, next coming all queries are easy. Okay, try to build up all these queries. So these are the questions. Okay, you need to write query like this. Okay, please understand that and try to write all queries by using sigma and pi symbols. Sigma means select operation, projection means select operation on column rows. If it is pi means projection means select operation on columns. If you want to display only particular column values, I can go for projection. If you want to display all the rows, sigma. Sigma means rows. Okay. See the order here. So first table, first table. Next inside the table we have the rows. So rows means we need to use sigma. So if I want to display, if I use sigma, all rows will going to be displayed. So if I want to only particular attribute, okay, particular column, then I can use projection. I can use projection. Projection means pi symbol, pi of id, the table name. Okay, so in this way I can write the queries. So please go through on this, try to execute it. Okay, okay, right. Thank you, ma. In the next session we will see everything remaining queries. So thanks for attending this session. You can leave the class now.